Alright guys, let's fix another LED bulb. So the bulb that you are seeing on your screen, it does not have any logo. That's because it's manufactured locally. Now once this LED gets failed, they get recycled, and it was recycled in a local market where they replaced it with these single board driverless LED modules, and it worked for about 2 years and then it stopped working. So you can see the connection is not connected properly, and that's why it got disconnected. So these modules heat up quite a bit, and due to this heat this wire turned brittle and it broke off easily. The insulation in the wire, it just turned to a crisp by prolonged heating of this bulb, and the internal conductor inside the wire, it got corroded, and over time it got disconnected. So the proper way to fix the connection wires are using fiberglass sleeves, so that the wires does not melt and touch with each other, and also they don't touch with the LED modules or any of the heat sink material. And also using a good quality wire is necessary here. So first I'm going to open it up and see whether this module is still functional or not. So I'm using a small knife here as a pry tool, and it appears that the thermal compound actually glued both the pieces together to a solid material, something, I don't know. It acted like a glue, and you can see there was not sufficient thermal compound applied, and as this module heated up, the thermal compound just dried and glued both the pieces together. That's why I had to use the knife as a pry tool. So you can see this wire is easily breaking off. That's not good. So basically this LEDs gets recycled most of the times, because initially they're made by branded companies like Philips, or like in India it's Bajaj, Philips, Siska, all those brands, and once they stopped working they get recycled. So in the market, easily available drivers are easily available, and the LED modules are easily available, and nowadays these driverless modules are really cheap. These modules are available in the local market at about 30 or 40 rupees, but on Amazon it's really high priced, but I believe in future it will be available at a cheaper price online. So this is the aluminum heatsink, and while opening it, it got a little bit distorted. The aluminum got bended, so I need to make it as flat as possible. So what I'm going to do is I'm going to sand it smooth, and I'm going to remove this thermal compound that is totally dried and solid, and then I'm going to make sure that it's completely flat, and I'm going to apply a little bit of thermal compound and then reattach it. So you can see it's completely hard and it's not coming off very easily, so I need to apply some force. So it's going to take some time to remove all this, so I'm not going to completely shoot the process. I'm going to cut wherever necessary. So after removing about 90% of all this solid thermal compound, I'm going to sand it smooth. So So it took me about 15 to 16 minutes just to get it clean. So you can see it's finally clean, and now I'm going to use a little bit more sandpaper and make it as smooth as possible. Okay, so finally it's completely sanded and it's super smooth, and the heatsink part is also flat. Okay, so now I'm going to replace the wire. So you can see as I bend it, it just breaks off, so it has turned completely brittle. The wire, the conductor inside, it's corroded and the insulation is flaking off. So this happened due to the heat that is produced by these LEDs. So here I'm using a series connected switchboard. So this incandescent bulb is connected in series with the mains line, and once it's shorted on the switch and the plug, the 100-watt incandescent bulb glows. So here you can see it's series connected. Now I'm going to test this module. So it works fine. Without the heatsink I cannot turn it on for a longer period of time, it will damage. So that's enough for testing. So I'm going to clean the connections with a little bit of solder flux, and then I'm going to reconnect the new wires. So to open the wires I'm going to use a little bit of solder flux on these terminals, and it's a B22 holder. So I'm going to hit it with my soldering iron and then open it up. So here I'm using my 25-watt soldering iron and it's not enough to heat it, so I'm going to use my bigger soldering iron. It's a wooden handle, 35-watt, not much of a power but enough to fix it. It's easily available all across India, very cheap and reliable soldering iron. Now the flux that I'm using, it's not a good quality flux, because once it gets heated it leaves a residue, a black residue, which I don't like at all. So here I'm using my soldering pump to remove the solder so that the wire hole appears and I can put a new wire through it. So this is the old wire. So here is the new piece of wire that I am putting in. So now let's solder it. So it's done. Now I'm going to pull out the second wire and then I'm going to put in a new wire. So I'm using the same technique. I'm pulling the wire with my left hand and then hitting the top portion, and the wire comes out really easily. And then I used my soldering pump to remove the excess solder, and then I put in the new wire and resolder it. So it was not that hard, but you need a powerful soldering iron because this 35-watt soldering iron was not enough here as well. 60 watt will do the job really nicely. So here what I'm doing is I am pressing the wire from underneath, from inside this bulb holder or case, and then I'm hitting the top part, and then the wire just easily comes out as the solder is melted. Okay, so here it came out. So I'm going to do the same process that I did with the other one. I'm going to bend this wire to the side and then fill this section with solder. So here I'm blowing the smoke out of my face because this smoke is not good if you inhale it. Okay, so it's completely done now. I'm wiping the excess flux that it had. Now I'm going to cut the wire into the required size, and then the process is really simple. So here what I'm doing is I'm going to remove the excess wire remnants that is still attached with this module. So I'm going to remove that piece of wire. So while working with these LEDs, one thing I learned is that these SMD chips can be easily replaced if you have a hot air blowgun or an SMD workstation or a halogen bulb, like 12-volt halogen bulb. You can heat the surface and then you can remove these SMD chips and you can replace these SMD chips easily. So these modules can be easily repaired. So taking some measurements. So I'm going to cut the wires according to the required length. Oops. So after stripping the wire, I'm going to apply a little bit of solder on the surface of the wire with a little bit of solder. So I've applied solder onto the surface, on the surface of this wire. Now I'm going to apply a little bit of thermal compound on the edge of this bulb case where the heatsink touches the outer side of this bulb case. So I'm applying thermal compound here for the efficient transfer of heat from the LED module to the cap and then to the entire body of this LED. It's not necessary actually, but still I'm applying a little bit. So I'm going to apply a little bit more on the edge of this cap as well. The best way to apply it is using fingers, because I can control how much I'm applying and the thickness of the thermal compound applied. I can feel it with my finger. Okay, so now let's put the cap. Now it fits in really smoothly, it does not need any pressure, just a light pressure and it fits in. Okay, so now a little bit of thermal compound on this cap, because when I sanded the surface it has tiny scratches and tiny dents which needs to be filled with thermal compound for effective heat transfer. I'm also going to apply thermal compound on the back side of the LED module. So it's nicely applied, and now I can fit it. So we're almost done here. After tightening both the screws, just make sure that this module does not moves, it stays still. And as I'm tightening the screws, I can feel that the thermal compound is coming out from the sides. So it's not moving and it's alright. So here I over tightened one screw and I just lost the thread. It was rotating freely after a certain point of tension. So make sure not to over tighten the screws, because the screw is made out of steel and it's tightening on an aluminum heatsink, so you might cut the thread. So over tightening is not necessary. Okay, so here I'm going to use the tweezers and then I'm going to bend the wires and then I'm going to solder them. So I'm going to bend them just like this way and solder them, but now I'm going to straighten them up and then fit in the fiberglass sleeves. So here I'm using a little bit bigger fiberglass sleeve so that it fits in tight and it keeps both the wires separated. So here you can see I'm putting in the second fiberglass sleeve, and these sleeves are actually recycled as well because I took it out from an old power supply. So with the help of tweezers I'm pushing it inside because it's slightly bigger than the hole, but it will do the job for now. Okay, so here you can see it's nicely fitted. And now I'm going to resolder it. So I'm going to turn this wire like a U shape, and then I'm going to make a small hook like shape on the edge of the wire and then solder it. So the reason this wire just comes out and makes a U-turn and then touches the module, that's because if it comes out directly and turns and I make the connection, then this wire is going to touch the module from the side, and over time the insulation might melt and it might get shorted. So that's why I used this fiberglass sleeve, and comes out and makes a U-turn and then touches the module. So this is I believe this is the actual way of doing it. So here I am fitting the second wire. And soldering it was not that hard, very easy, very simple. I'm just blowing into the solder joints to cool it down first. And you can see it's completely done. So it's a 12-watt module, SMD 2835. I believe that's the model of the SMD chips, 2835. Okay, so now I'm going to test it. I'm going to use my series connection board and I'm going to test it right now. So here I'm going to short out this socket to complete the series connection into a direct connection. And it works. So with the diffuser attached, you are not going to see the wires in the middle, and it's going to work like normal LED bulb. So here is the thumbs up, that means it's fine. So in this way you can fix LED bulbs. This is just another way, and more videos are coming ahead about LED bulbs. So thanks a lot for watching, guys. Hit the like button and share it with your friends, and if you're new, then subscribe to my channel. So thanks once again for watching. I'll see you soon. Have a nice day. Take care. Bye bye.